So today we talk about embedded vision or smart cameras. Um, choose the right solution with EyeVision. Of course, the question is always um, how to make a solution. Basically, um, what is a smart camera? It's only a piece of hardware. Without software, it's not working. And therefore, you need at the end a software which operates whatever you want to do in the machine vision area. And the same is, 1 second, I have someone else here in the waiting room. Yeah, so it's working here. So the question is always how to make a solution, either with a smart camera or with an embedded vision system, and what is the cons and pros for both of the systems. So to have a short idea what kind of systems are available, I have only here a few smart cameras. There are a lot more which are also supported with the software. And here I have I think one of the well-known embedded hardware products. This is the Raspberry Pi. We also support, for example, the NVIDIA Tegra, the Odroid, and many more. So we use for today simply this embedded system as placeholder for all the others. And we'll think about why should you use a smart camera, or why you should use or when you want to use an embedded system, and why to use a smart camera. So smart cameras are now a somewhat old technology from the end of the last century. In roughly 1996, the first smart camera appeared in the market. And at that time, it was, let's say, a cheap way to make machine vision. And because at that time, the machine vision systems were mostly based on VME bus systems. Nobody knows it today. They're really expensive hardware. At that time, the PC was not an option. It was much too slow and with a lot of restrictions. So you could do only very little for a very high price with the PC. And if you compare it with the systems here on the first slide, a PC was much slower than any of the Raspberry Pis. An actual Raspberry Pi or embedded system is on the level of a current, not high-end PC, but on a current PC. So that's why even these embedded systems allow us to make nice solutions. Yeah, Phil, maybe a few words about EVT, but only a few. If you need more information, you're welcome to visit our website and have a closer look to it. EVT, the main product of EVT is the EyeVision software, which works on all these different hardware platforms. Means you can run it on different smart cameras, embedded systems, but also on all kind of PC systems with either Windows and Linux. And we have a tool set for all main image technologies like line scan camera or any area scan camera, 3D, thermal, and hyperspectral imaging technologies. Finally, also for X-ray and terahertz systems. So you have the choice of the right camera. And we still develop the software. So we have a really powerful AI um, tool set in the software, as well as robot adaptation to make robot solutions. EVT is located in Germany. The headquarters is in Germany. It's in Karlsruhe, where we are today, or where the webinar is held today. Then we have EVT China in Shanghai, which supports the Chinese Asian market, and EVT Korea, which supports mainly the Korean Japanese market. And around the world, we have different distributors. To have a short overview and why we can talk about smart cameras, embedded system, and all the other stuff. With the EyeVision software, we support smart cameras and embedded systems. And I think you saw it, of course. We support different operating systems and all kind of image capture hardware, which I just mentioned before. So this is a basic idea or the basic which allows us to have a rough overview or can give you a rough overview what might be good or not good. So the software has a lot of different tools inside, and I have here a short overview where you could use or where some of the hardware platforms might be very good. For example, if you have mainly metrology, of course, you can use a smart camera and embedded vision platform. Of course, you can use any other vision system for that. But today we mainly want to focus on smart cameras and embedded vision systems. And the same is for 1D, 2D, 3D. In most cases, you can use a smart camera or embedded vision system. For thermal imaging, there are roughly not so many thermal cameras with an integrated CPU. So therefore, mostly embedded vision system fits very good. It's the same for the hyperspectral. And in many cases, you can do AI deep learning on the smart camera and embedded platform, depending on what smart camera you are using. And the same is for a robot vision solution. If you have simple robot vision solutions, although these smart camera or an embedded vision platform fits very well. Maybe before we go somewhat deeper, what are smart cameras? Maybe most of you know it, but I want to to bring everybody on the same level. A smart camera at the end is the complete embedded hardware platform in one housing. So that means you have a sensor, image sensor in the housing. You have a CPU inside, and of course you have PLC I/O. And finally, if it's not only a brick, then you need also some software. Only the software makes a smart camera valuable. If you look back, maybe in the last century, the smart cameras are based on at that time state-of-the-art microcomputers or microcontrollers with limited hardware. If you look to the current smart cameras, like the two I have here selected, but there, as you saw in the first picture, there are many more which we support. Most of them have nowadays either an ARM CPU, it's a majority, or a an x86 CPU, and have therefore integrated also an operating system due to the needed memory size, mostly Linux, but of course there are also some smart cameras with Windows. And so a smart camera means is a very compact, fully integrated embedded system. If you look at with a housing, if you remove the housing, you have an embedded system. If you have a housing, then you have mostly a smart camera, either with a sensor in the topmost camera and the CPU inside, or in the lower, you have sensor, the light, and the CPU, and of course the I/O system. Due to limited space, most of the smart cameras have limited I/O capabilities. That means they have Ethernet connection in most cases, and some PLC I/O and a power connection. Of course, for the main target, it's simply enough because the tasks originally intended for smart cameras are not the general purpose tasks. They are reduced to some specialized tasks. Even if the CPU power in the current systems, the ARM CPUs are so powerful that you can run most of the complete software, 2D software packages, in some cases also a 3D software package, so that there is no limitation. And maybe you have the limitation only in the connection to the environment. But anyway, if you have a look to the top camera on the back, you see here there additionally are some USB and also an HDMI port to connect the monitor directly. But this is somewhat not what a smart camera should have and should be, because the idea was finally to have, let's say, plug-and-play solution for vision applications. That means if you want to read, for example, a DMC code, you use this smart camera only with the DMC code reader part of the software, and then you can do a DMC code reading. Because of the enlarged CPU power, or the more powerful ARM CPUs, you can also combine meanwhile the software which is available for measuring and for object tracking and so on. And because the communication switched from PLC I/O, which was at the very beginning the main communication to the machine, to the more communication-based I/O, that means Profinet, Modbus, or all these other bus-oriented communication. There's no real problem because of the limited connectors. As well, the programming as well, the I/O can be handled over the let's say mostly Ethernet protocol, so that the limitation which was originally based on the limited space on the backside has vanished, and you can use it as any other vision system. In most cases, even a PC system communicates to the PLC over a standard bus protocol. Therefore, the major advantage is you don't need any cabinet. You simply connect the camera, connect the power, mostly 24-volt from the machine, and you're ready to go. That's one of the major advantages of the smart camera. Maybe some of you also heard about the vision sensor. If you look to vision sensors, it's a smart camera, and the difference between vision sensor and smart camera is in most cases only the amount of software which is in the sensor. And as I told you, the cameras nowadays have enough. Oh, sorry, I just saw someone else want to enter. The cameras have so much memory that you can run all the software inside. So it's not a real need to have these vision sensors. Of course, at the very beginning in the last century, smart cameras have limited main memory, so maybe 256 kilobyte. Nobody knows how less memory it is nowadays, and maybe only a few megabytes um, of flash memory, SSD memory, where you can store things. You had mostly the need to make these smaller sensors, but due to the improvement in CPU and memory capabilities, nowadays most of the smart cameras are vision sensors and vice versa, or most of the vision sensors can be a smart camera based on the software which is in the camera. What is an embedded system? I just mentioned it during the explanation of the smart camera. An embedded system is mainly, let's say, a kind of PCB which integrates all the CPU, the main memory, and any kind of I/O capabilities. In this example here, but also if we use the NVIDIA Tegra or the NVIDIA platforms, not only the Tegra, also the newer ones, you have on these platforms this specialized interface to sensors. In this case, it's called MIPI. MIPI is mainly developed for the smart camera, for the not smart cameras, for the smartphones, and can be used nowadays for machine vision applications, of course. It's an interface how to connect sensors directly to the main CPU. Of course, the MIPI focus is a little bit different to main applications than for machine vision. But there are also a lot of machine vision tasks where the MIPI is enough and works very well. So you can use always MIPI you can use in many cases MIPI for the machine vision application. But because the main connections are now standard, you will find on nearly all embedded platforms these standard interfaces like gigabit Ethernet, USB 3, and in many cases you will find also RS-232. Of course, it's an outdated interface, but there's still a lot of I/O hardware which can be used with these connectors. So you can use the embedded platforms either with these, let's say, specialized MIPI cameras, which might be also really interesting if the camera is in the same housing and you don't need, for example, a very high-speed trigger interface and so on, then the MIPI camera is a really good option. In all other cases, you have the option to use any of the GigE or USB cameras to connect it to the hardware and capture the images for the machine vision solution. One of the major advantages to the smart cameras is more powerful CPU. So in most cases, it's also an ARM CPU. But of course, if you have only these small housing from the smart cameras, one of the problems is how to handle the heat from the CPUs, and this is a limiting factor. Of course, you can build in always much more powerful CPUs, but at the end, the heat, you have to eliminate the heat out of the housing, and therefore there is a restriction. When this restriction is not there, if you use these embedded platforms, you can use more powerful, mostly ARM CPUs, and run all the software which you run on any PC in generally, as long as the software is available for ARM platforms. And of course, also because it's not so restricted in space, you find on these embedded systems the same amount of main memory like you will find it on in a PC, nearly the same, not all. And so it means you can run all the PC tasks in these embedded platforms, all the tasks which you run on a PC on these embedded platforms. Of course, there are limitations, and mainly in the option to add additionally hardware, which I just mentioned it at the very beginning. AI is, let's say, a still growing part of the machine vision solution. And of course, we also have this AI part in the software. And if you use these embedded systems, you have not the option to add, in most cases, any additional AI hardware, which means you have to run the AI on the CPU or maybe on some dedicated specialized hardware, which is mostly not so powerful as on a PC. That means if you have a smart camera or embedded platform, either you have a CPU inside which has some ability to run to operate the tensors from AI operations, or the CPU has to run it, and it simply results in the speed of the solution. Therefore, the limitations in smart cameras are somewhat more limited than in embedded platforms. Most of the smart cameras have only ARM CPU inside. There are some smart cameras with now an ARM CPU and an integer TensorFlow unit like the NXP CPU, which is an ARM CPU with a co-processor inside. In embedded systems, mostly you find an NVIDIA board, which enables you to run the standard NVIDIA tool set, and therefore also the standard AI tools. Of course, with a limited power based on the size. If you look to some of the NVIDIA graphic boards, you can imagine it's not fitting in an embedded system. But you have more power on the embedded platform than in the smart camera. Of course, the flexibility from smart cameras is limited, especially if you have, it's for many applications really nice. You have the built-in lens and light, which makes it really compact and robust and easy to install. Of course, if the integrated lens and light is not fitting, then you cannot use it. For the embedded systems, also with the MIPI modules, you have this separate camera. That means you have or can use any lens, but you have to select one and buy it. You have to add the light. And with this, you have much more flexibility or a higher flexibility. But you have to do it. So depending on the tasks, in some cases, the flexibility is the key factor for the solution, especially if you build embedded system as a solution. We will see later some examples. Then this is the advantage related to the smart cameras. As I just mentioned, the performance is on embedded systems mostly higher than on smart cameras, simply because the design cycle is faster, and you get in most cases the newer CPUs. Newer CPUs means much faster CPU power. On the other side, if we look into the industries, okay, I have to accept two other. In most cases, if you if you want to make solutions, the smart camera gives you a quicker solution. A quicker solution because you simply use the smart camera, connect your power supply, and you are ready to go to make to solve the task for your customer. The embedded system on the other side, of course, requires configuration, gives you the flexibility nearly of a PC system to make a solution. These are the major advantages between the smart camera and the embedded system. You have to do, that's the thing, you have to do the selection of the lens and the light as you have to do it on a PC system. Cost-wise, of course, smart cameras, if you use the total cost, you get a ready-to-use component which immediately starts to work when you power it up. If you use an embedded system, you get a PCB, you get some software and the camera, and you have to connect it. So you have to invest some time in most cases. Not the hardware costs are, I think, similar, but the invested time has to take in your mind. And then, of course, price-wise, the embedded vision is on the same cost level at the end than a smart camera. Of course, if you need the higher flexibility, the smart camera will give you no, the embedded system will give you more flexibility to make your solution. Here, I just mentioned it a little bit because I like all this hardware. As I said before, the advantage of the smart camera is the easy installation and deployment, because you have this, in this case, small little camera. You have the built-in light, the built-in lens, and on the back side you have a power connector and Ethernet connector. You simply attach it wherever you have to do something, and maybe you have, if you only want, for example, to read a DMC code, like in this example, you simply add the DMC code to the program editor or to the recipe, and that's it. So you're finished. You don't think about a cabinet, the housing, and so on. Of course, the built-in light and lens have to fit. If it's not fitting, it's not working. As you can see here, and we have a look to the software later, you see here all the 2D tool sets, because the smart camera is with the current CPU power so powerful that you can use all the tools to make a solution, a 2D solution, or if you have a line scan smart camera, a 1D line scan camera solution. So because you buy the smart camera as a complete set, the software is pre-installed from the manufacturer. You also don't have to think about the software. You plug it, you plug in the smart camera, and the software starts up, and you only, in this case, have to take the DMC code reader, and that's it. It's much faster than if you use an embedded system. And because you don't have a cabinet and some other adjustment stuff, the maintenance is much faster because nobody can change anything in the smart cameras. It's everything included. And of course, no cabinet. You have hopefully the machine normally has the 24-volt power connector, and with the 24-volt, you power it up. You connect the Ethernet connector, and maybe if you only need a good bad signal, you can use the PLC I/O, which is integrated on the backside here, or you simply use one of the protocols like Profinet, Modbus, and so on to communicate with the machine to generate the good bad result. Or if you have a reading application like the DMC code, you simply can transfer the resulting string from the reading to your machine if it's interested. So that's the powerful thing. Of course, if you need more than a few I/O lines, then you have, that's it. Either you have to add more I/O lines over any special component like I/O interface board, which you can connect and over Ethernet, for example, or you need, for example, PLC, and you connect over Profinet or Modbus with the PLC to add your I/O capabilities as long as the machine doesn't support the direct communication. Of course, I just mentioned it, the disadvantage is the limited CPU power. If you start, for example, with a simple DMC code reader and you are happy with it and it works also fast. You see here, it's 90 milliseconds for the DMC code reading. Everything is perfect, but maybe in many cases, you start with a DMC code application, and then the customer realize, I need maybe this or that, and then you start, because you have the software, you start adding all the features, and finally you reach the point where either the memory exceeds or the speed exceeds. That means as more functionality you add to the program, the longer it takes, and you cannot improve the CPU speed. That means maybe you reach at one point the speed constraint and you cannot solve the task. And at that point, you don't have flexibility. You simply have to replace the complete smart camera and replace it with either a more powerful smart camera or with a PC or embedded system. If you that's one of the major disadvantages. You have then to simply replace it completely. So before you start with the solution, it's always important to know what kind of solution have to be done, and is it exactly what is needed, or do I need some additional CPU power for the future? And if so, maybe you have to buy immediately the more powerful smart camera, or you have to select something else. If you look the other side to the embedded systems, I just mentioned it before. There are a lot of embedded systems, and one of the major advantages is either you use this MIPI sensor, or as you can see it here, you simply connect a USB camera directly to your embedded board, whatever it is. Here you have a real big choice of embedded boards with different CPUs inside. Here on the lower part, we see, for example, the NVIDIA board, which has an integrated AI, or it has an NVIDIA graphic GPU inside, which makes AI powerful. If you use maybe any other board like this one here, which has an ARM CPU, but maybe it has also, most of them has now also the option for an PCI Express connector, then you have the option to use these additional boards to run AI, like the Halo or the Coral AI board, which gives you more CPU speed or more special tensor speed to run AI on these boards. And of course, as the nature there gives you for the embedded boards, you have always the option to add more storage memory to the system, or in many cases, you also can order it with different main memory capabilities, which allows you at the end also to run 3D tasks on these embedded systems. What are the disadvantages of the embedded systems? Mainly here we see we have an initial higher cost. Of course, you buy the embedded system and you need anyhow any kind of housing. Either you organize a cabinet where you integrate the embedded system, or you build a special housing. That means it takes some time until it's integrated. And if you have only a very simple task, the smart camera with the built-in housing is much faster. Of course, the embedded systems, as I just mentioned it, we support a lot of these embedded architectural systems or platforms. Someone have to set up the software for these systems. Mostly you get the PCB and you have to install the operating system. In this case, mainly it's a Linux operating system. Then you can get the EyeVision software, for example, and you have to set up the EyeVision software. And finally, then you can connect a camera to it. Either if it's a MIPI camera, a USB camera, or a GigE camera. Of course, if the system is running and the EyeVision software is running, it's exactly the same like on a PC. You simply select what kind of camera you want to use, and it's running, but you have to do it. It's simply not take it, connect it, and it works. You need some more time to make it up and running, but therefore you have the flexibility to add the factors you need. And of course, you need some housing. It's not so small than a smart camera. It's always bigger. Even if you make a nice compact housing. So finally, the question is when to use smart cameras. I think the result of what I said before, for simple quality inspection, that fits very well. So if you have to count objects on a belt, or if you have to read some barcodes or OCR or whatever, if you have to check the presence or absence from parts, also to locate objects on a production belt, to do some simple pick and place applications, then a smart camera is always a good choice. And of course, if you don't want to do a lot of integration work, you simply have to solve the task. You select for the tasks the right smart camera, of course, based on speed constraints. Especially if you want to do multiple tasks, you have to have in your background the speed of the smart camera, that's the speed of the CPU of the smart camera, depending on the production line. Smart cameras have their limited CPU power, and of course, you can always read, in this case, it's fast. You can always read OCR with a smart camera. But if the production speed is too high, then you cannot meet the speed of the production. So maybe then the smart camera is not fitting, even if the task can be solved. Software, on the software side, the speed limitations might be the key problem for the smart camera solution. So that's one of the things what you always have to have in mind when you think about a smart camera. Even a simple quality inspection is suddenly difficult if maybe the production speed is at 40 parts per second. Then the inspection might be not the problem for the smart camera, but the speed is the problem for the smart camera. And with the speed, you're at a point where the solution is makes no sense, because you don't want to reduce the production speed of, or most of the people don't want to reduce the production speed. So smart cameras are really good if you have a standard application with a standard speed, and you simply want to attach the camera to the production belt and select the right tools, and then it works. And the good thing is the full tool set is working, so you are not restricted based on tools. You are only restricted based on hardware requirements. When use embedded systems, one clear part is exactly what I said to the smart cameras. If the production speed is very high, you need more CPU power, and more CPU power is available in embedded systems, or of course in PC systems. But we want to talk today about embedded systems. There are very powerful embedded systems which are on the level of let's say medium-sized PC. So we can do with these embedded systems also 3D applications. Like you can see here, this is a CAN inspection with a 3D laser triangulation. You can run this without any problem on an embedded system. The 3D always has the constraint, it needs more main memory to hold the 3D data. And of course, more main memory, higher speeds means you need a more powerful CPU. Therefore, in this case, NVIDIA is a real good solution. Of course, there are some other ARM CPUs which are really also very fast. Maybe, for example, the Apple ARM CPUs are really powerful. Okay, they are not embedded. They are not an embedded platform. I just searched for another ARM embedded platform which is so powerful. But for many cases, the current Raspberry Pi, for example, or Odoo platforms are so fast that you can run this 3D application also on that platforms with either in most cases with the ARM CPU as main processor. Of course, if you think about AI, then either you use these once again NVIDIA platform, or you select a platform, an embedded platform, for example, the Raspberry Pi, which has this PCI Express interface now, which allows you then to use, which I mentioned before, these two speed improvement hardware platforms for AI. So Halo is the latest uh, hardware improvement for embedded systems. It's really powerful and it enables AI in many embedded solutions, especially also with a very small power footprint, which is an embedded platform anyway important um, to have not these high power graphic boards inside, which needs also cooling. So that's one of the uh, basic ideas when you use embedded system. If you have a medium-sized AI, uh, and of course, multi-camera, I just forgotten to mention it. If you have a smart camera always has one sensor because you have one housing and this housing has space for one sensor. That means if you need more than one sensor, either you use two smart cameras and therefore you have to handle also two times the software and everything, which makes the task really complex. And so the advantage of the embedded platform in the multi-camera environment is you simply plug two, let's say, non-smart cameras to the platform, and you can handle it in one program. So the complexity factor is much smaller. And if we at the point when you are using multiple cameras, the cost factor of embedded system is at this point much better because if you use a smart camera, you buy two times the complete hardware. Not only the sensor, you have to buy the CPU and of course the software. If you use an embedded system and you connect to the embedded system the standard camera, then you only have to add a second camera, and you have the CPU and software part only once, which generates immediately a price advantage for these solutions. And if you have more than two cameras, three, four, five, then finally, immediately, price-wise, the embedded system is the much better solution. Here I have some examples of industry applications uh, where to use a smart camera or where to use an embedded system. And of course, the question is here, especially that's why I selected it, are these embedded systems or are these now smart cameras? Because I targeted smart camera to say, okay, we have the CPU, the camera, the lens, the light in one housing, and of course the software. And if we look to these four systems here from the semiconductor industry, of course, this is a particle inspection for the semiconductor industry. This is a five-side inspection for the semiconductor industry. Inside of this housing and of this housing, there is an ARM CPU here with a MIPI camera. Here on the front side, we have a mirror with a light on the bottom side to have front light situation, and we have some side lights here. So at the end, this is a smart camera or is the embedded system because, of course, it's a standard embedded board inside with a MIPI camera. Here the advantage is we have all the IOs from the embedded system and also the speed improvement for AI inside of one system. So in this case, it's because it's special built for this industry. it's an embedded system with a housing, but because now it's a finalized system and it's ready to sell, it could also be used as a standard smart camera, of course, with the constraint that the parts have to fit inside of this inspection area. And here for the particle inspect, this is a classical embedded system. We have in the bottom side a complete embedded system with the standard, in this case, NVIDIA CPU with the ability to run the AI. And we have here on top a line scan camera, and this is the probe area where the line scan camera captures the probe, and the resulting images are analyzed to make the solution. So well, let's go back. No, back. So this is the reason why I said it's difficult to switch between classical camera. Of course, in this case, if there is a smart line scan camera, you could solve this task if you don't use the AI part of the software also with a smart camera. But in this case, the solution with a standard line scan camera and the embedded system with the ability to run the AI to do the particle analysis is much more powerful. Therefore, this was the right solution for it. And here we have another smart camera. This is a dual head smart embedded system. So we cannot see it. We have two cameras. We have one here and one here. And we have here the filament. Normally, the filament runs through the system. And in this case, you could use effectively two smart cameras to do the task. But because these are two heads and the advantage of an embedded system where you can connect the two cameras to it makes the system cheaper than two smart cameras. And also here, this is a special inspection task with 4 cameras, which does inspection on glass plate. And we have here a big housing to handle the lens and the light stuff. But here integrated is the embedded system. So also a nice embedded solution. That means in all cases, if you have more complex tasks, in most cases the embedded systems are the better solution, especially if we have a look here to this example. Of course, 2 smart cameras would do the task, but 2 smart cameras are price-wise not the right solution, even if they can do it. And yes, why EyeVision? Of course, I mentioned it sometimes. If you have a smart camera or an embedded system or even a PC system, without the software, it's a brick. It cannot do anything. And in any case, it's really nice if you want to change between the tasks, or if you start with a smart camera task, or let's say a simple DMC code reader task is a smart camera, and if you have to change the hardware because maybe the CPU speed is not fast enough or the resolution, you don't get the smart camera with the right resolution, you have to change. And most of the time, what you need is to train to the software. It's as if you're doing text, if you have to write a text, Normally you use Word because you know Word. And if, of course, you can write the text always with any other type writing software. But uh, as you never change your text processing software, um, because you know how to handle it. Mostly it's the same if you know how to handle, for example, the software for the smart camera. It's much easier if you have the same software on, for example, the embedded system or the PC system. And that's why, in this case, EyeVision makes it easier for you to change between these hardware platforms. Each of the hardware platform has its advantage, which allows you to handle the different tasks. Um, but at the end, the software is the key factor which allows you to make the task, to solve the task. And if you don't have to change between the hardware, the software, you are always on the same level and you are much faster in the solution. Independently, if you have a smart camera without a user interface where you can use, for example, this remote version of the software, for example, where you simply connect to your smart camera. You see here the smart camera, and then you simply program it over Ethernet. Or if you have maybe a smart camera or embedded system where the complete software runs on it, there at the end, there's no difference. You have the tool set on both sides, and you simply program it the same way. And therefore, you can also scale scale it to the hardware and the solution task, so that you don't have to think about, oh, maybe it's too expensive if I only have to do the DMC code reading on a smart camera. You get then only the DMC code reader from the software. And if you need more, you can add it at any time. And here, finally, I have one solution for an embedded system. Once more, an embedded system. Here, this is the iSorter. This is a specialized tool which can do sorting of parts from ball feeders. So, of course, it was the same thing. You could use a smart camera and you have to attach it to the ball feeder. Anyhow, you need a light and a lens. Of course, in this case, you need a line scan camera. So there are not so many smart cameras with line scan option, with a line sensor option. So in this case, the embedded system was the right solution. You have here an embedded system inside where the line scan sensor is directly connected to the embedded system. And in this case, of course, there is also an additional display output to the system, so that you have a complete ready-made solution. And of course, you have also the PLC-I/O. So that means at the end, this iSorter is more a classical smart camera, because it has a lens, it has a light, CPU capability, and it has the software, and it has built-in PLC-I/O. You don't need a cabinet. It's a smart camera. If we remove the housing, of course, it's an embedded system, but with the housing, it's more a smart camera. So the question is, what is the right solution? Is depending finally on the task you want to solve and you have to solve, and therefore you always have to think what hardware fits best to the solution. That's the right hardware. There are so many smart cameras in the market that you always will find one which might be good for which is good for the case you want to solve. Or if you don't find it, of course, you will find an embedded system which allows you to do the task, as I just showed it with the last few examples on how to make solutions or how to make this, when to use the embedded system or the smart camera. It's really not very easy to say, okay, the smart camera is always fitting for that or for that. Of course, if you have very simple tasks, and there are so many in industrial applications like code reading, object counting, object tracking, and so on, where a smart camera fits perfect. And if you need the flexibility or you don't know the speed constraint and everything, maybe the embedded system or finally also the PC is a PC with a connected camera is a good solution. Which fits best? Either you have to test it in upfront, or of course you are always welcome to contact us, and we can give you some ideas which hardware would fit for which task. So if it's an embedded task like this one or a robot task like this one, we can give you some ideas what might be which options you have and what will help you. So simply feel free and contact us at any time. We will help you. If you have some questions about smart cameras or embedded systems, please feel free to ask me now. I think I can answer most of them. And yes, if not, I would close the session for today. You have here our contact information. So you can write us always with this email address. For all registered, you get a download link for the software, so you can test the software. You can test the software on all embedded systems. If you have a specialized embedded system, for example, if you want to use NVIDIA, let us know. We have the standard set up systems available for normally for the Raspberry Pi, but if you need NVIDIA, let us know NVIDIA. Or if you have Autoread, for example, or Orange Pi or Banana Pi or some of the other ARM-based systems, simply write us a short mail and you get a specialized download link for that hardware. The selection of the cameras is built in the software. So you, after the download, you simply can select in the hardware configurator which hardware you want to use. This belongs also to the MIPI interfaces. If you use an embedded board with an MIPI interface, or like, as I showed before, the Raspberry Pi, but also NVIDIA or Orange Pi or whatever, you can select, in that case, Video for Linux. This driver will support the MIPI camera interface so that it's very easy. For this, I also want to remark that we have the Academy. This is on our webpage, a special area. We have a lot of videos how to set up, how to install the camera, and so on. So that you have always the needed information at your fingertips. And yes, now I'm here for some questions. Or I would say simply thank you. And in this case, I will close up and hope to see you again. Bye-bye.